I write the parallel slope, because this is the new slope that I'm going to use for my new line. Even though it's exactly the same, there's nothing different about it, but it just helps me distinguish the difference between them. Because if I was looking for perpendicular, so again, I'm not, but if I was looking for a and this is a notation for perpendicular, so let me put that over here. It's like this upside down capital T, and for parallel, is these two dash lines, slanted lines, like forward slash. 2 forward slashes. If I was doing perpendicular, I would have to do reciprocal. So instead of 1 over 4, it'd be 4 over 1. And then instead of being negative, it would have been positive, which is the same thing as just saying 4. But again, this is for perpendicular. But I always like to distinguish, okay, I did all this work. I have the slope from this line, and then I write the slope again, depending if the slope has to be parallel or the slope has to be perpendicular. But since this is asking for a parallel slope, that means I'm going to plug in this one. So I have y minus, and then I have to plug in my y coordinate, which my y coordinate is 1. Close that, equal to, and again, I'm using the parallel slope, not the perpendicular, parallel slope, which is just exactly the same. So I'm going to write negative 1 over 4, and then x minus, and my x coordinate is negative 4. So you want to be careful, negative 4. Sorry, I kind of squeezed that in there. But this will simplify to y minus 1 equal to, and then I have to distribute this negative 4. It's going to be negative 1 over 4x. These two negatives become a positive, but then this negative times that positive is going to be negative. And if you do, again, you can always do the work on the side if you want. I'll bring this sheet of paper back in. And we would do 1/4 times, we're not adding this time, times 4. So remember, to multiply fractions, you always multiply them straight across. But to multiply this straight across, I need to have something here in the denominator. But if you remember the shortcut, that you know that 4 divided by 4 gives you 1. And then 1 divided by 1 is just going to be 1. So everything simplifies to exactly just 1. So I'd be left with a negative 1. And don't forget, this is technically the equation that's parallel to this line. But the question, if you go back and read the question, it asks you to write this equation in slope-intercept form. So to do that, I need to add a 1 to both sides. This is going to cancel here. And then you're going to be left with y is equal to negative 1 over 4x. And then 1 plus 1. Here, again, it cancels. And that's it. There's nothing over here. I mean, if you want to think about it as something being there, it's just like saying plus 0. Even though we're never going to write that. But this is our answer here. But technically, there's like a plus 0 there. And again, if we compare these two with each other, so that's here, they have the same slope, but the y-intercept for this one, if I was identifying the y-intercept, remember the y-intercept is a point. So the y-intercept here is 0, 3 over 4. Where here, my y-intercept would be 0, 0. So you want to be careful with that. And that's it. That's the third type of problems in here in terms of asking for writing a linear equation. Again, if it was asking you to do a perpendicular one, let's say if we change the question around and instead of asking for parallel, it asks for perpendicular, again, we would follow all the same steps. The only thing that will change is instead of plugging in this negative 1 over 4, I would just plug in the perpendicular slope, which was the reciprocal of this and the opposite sign. So it would be positive 4x minus, and we'll still have the same point. The point hasn't changed. These two are going to become positive. This stays y minus 1. And when I distribute, it's going to be 4x, and 4 times 4, because it's going to be a positive 4, is going to be positive 16. And then we add the 1 to both sides. Y is equal to 4x plus 17. Again, for perpendicular, has nothing to do with the y-intercept. It's strictly just on the slope. But this would be our answer if, instead of asking us for the lines to be parallel, it would have asked us for the lines to be perpendicular. If it was asking us for perpendicular instead of parallel, this would be our answer right here. So, again, to reiterate, there's 3 types of examples. I'll go back to this. You have, it's either, you're going to write, we always need a point and a slope. They're either going to give you that, or they're going to give you 2 points, or they're going to give you a linear equation and a point. But for these examples, it's going to deal with parallel and perpendicular lines, which you just need to do those extra steps for them. So let me give you some homework on this section. So don't mind that picture in the drawing, but here's your homework. So it's going to be 5, 8, 13, 14, 17, 19, 21, 23, 26, 28, 37, 39, 41. So I know it's a good amount of problems. That's 1, 2, 3, 4, 5, 6, 7, 8, 13. So it's not too bad, but it's literally one of each of these. And a couple of them have to do with this idea here that I know I didn't go over, but I'll post a video about this. So try to see if you have any questions about. There's going to be a couple examples that have to do with this. If you have any questions, let me know, and I'll post a video on this soon. But you can still do, there's only like 2 or 3 of that, but then you can still work on the rest of these problems. So try getting these done. Again, do your homework, take pictures of it, convert the pictures to PDF, and email them to me. And we'll be taking a quiz soon. I'm thinking I'll either post it Sunday or Monday, and it's going to involve 1.8. That'll be 1.8. It'll be 3.6. It'd be 2.4, and probably this 2.5. I think that's everything that we covered. So 1.8, 3.6, 2.4, 2.5. I think that's everything I've done. I'm going to continue teaching and posting new videos, but the test is only going to be on, again, 1.8, 3.6, 2.4, 2.8. So 1.8 was solving linear equations and solving absolute value linear equations. And then 3.6 was about that was 1.8. 3.6 was looking at polynomial, which were non-linear. 1.8 was inequalities and absolute value inequalities. inequalities. 3.6 was looking at nonlinear inequalities. Then, actually, I think I did a little bit of 2.1, but the main idea is being able to graph a linear equation using either a table or point slope form, and then these writing linear equations. So I'll email that to everybody, but again, it's just the last videos that that we did after everything up till now. That any videos that are online, it's basically all the videos up to this video. Okay, bye bye.